All right, let's finish off 6.1. I didn't really realize how little there was left. I just felt like that second video was getting a little long. And so these are the last three problems that remain. And again, all of these have their counterparts within the body of our homework. And so as we go to the cosine inverse of sine of 7 pi over 6, well, here we need to just work this a little bit at a time. We work outside in. So let's just leave this cosine inverse for a minute. And we know from our first test what the sine of 7 pi over 6 is. Let's remind ourselves where 7 pi over 6 is. It's just beyond pi over 6. And so in particular, it's in quadrant 3. So the sine of it's going to be negative. Well, it's related to a pi over 6 angle, right? So this right here, I was trying to write pi over 6. That may be unreadable there. And so we know what the sine of pi over 6 is. It's 1/2. Cosine inverse of negative 1/2. Well, I got to think about where cosine inverse can go. It can go in the first quadrant and then into the second. This is going to be a second quadrant angle. And the cosine inverse of 1/2, the angle that I take the cosine of to get 1/2 is pi over 3. And so it's an over 3 angle, but in the second quadrant. And we get 2 pi over 3, a familiar problem from before as well. These are very good. These problems that come next, I would be shocked if they didn't make the test. I tend to pick something like this because it has you draw things out. So, and test for understanding. So they're asking us to take the cotangent of the arcsine of u, and they do tell us that u is a positive number. That's important. Because u is a positive number, we know we're in the first quadrant. And what we know is arcsine of u is some angle theta. So we'll name this angle theta. And so this, what we know is the sine of theta is equal to u. Well, we know sine is opposite over hypotenuse. We need to get the cotangent. So we're wanting to get the cotangent of this angle, right? Because what arcsine does is it produces this angle that we'll never know. But we don't need to know it because we know its sine is u over 1. And so we know that cotangent of this angle that we want to find is adjacent over opposite. So we already know that it's something over u. The question is, what's this adjacent side? Well, let's go find it. I know that a squared plus u squared needs to be equal to 1 squared. I know that a squared then is equal to 1 minus u squared. So a is equal to technically plus or minus the square root of 1 minus u squared. But you and I know, because it's in the first quadrant, that that's a positive x direction, and it's the positive square root. So what's this equal to right here? The cotangent of that angle is the adjacent side, which we just found out is 1 minus u squared, all under the square root of 1 minus u squared over u. So the answer to this one is the square root of 1 minus u squared all over u. So it's really important that we realize that what we're finding when we take an arcsine or something like that, we're trying to find the angle whose sine is u. And so we never have to know that angle for this problem. We just know that it's in the first quadrant. What about something like this? Secant of cosine inverse of u squared plus 5. Well, this one's done if you know what's being said. They're telling us that the cosine of an angle is equal to u over the square root of u squared plus 5. And they're asking for the secant. Well, we know secant's 1 over cosine. So there's nothing to do here other than to apply your trig relationships and say the answer is the square root of u squared plus 5 all over u, because that's what a secant would do. It would flip a cosine value. Remember, this is the value of the cosine. What we're not seeing is the angle, but who cares? Because in the end, we're applying a trig function and we never even need to know the angle. That's the power of trig, is that we can get by not knowing some things and just manipulate what we already know. Okay, so ideally in the end, when we give you something like this on the test, sine inverse of negative root 3 over 2, that you're thinking this: oh, I'm looking for something between minus pi over 2 to pi over 2. and actually let me not just say something. This thing is saying, find theta that's an element of minus pi over 2 to pi over 2, such that sine of theta is equal to negative root 3 over 2. And we know this angle. This is a pi over 3 angle, but it can't be pi over 3 because the sine of pi over 3 is positive. It's got to be negative pi over 3 because sine in the fourth quadrant is negative, which is where minus pi over 3 lies. We want you to know that when we're asking you to find the cosine inverse of negative root 3 over 2, that you say to yourself, oh, I'm bound between 0 and pi. Okay, cosine of what angle is negative root 3 over 2? Well, let's just worry about root 3 over 2. That's pi over 6. Well, it can't be pi over 6 because the cosine of pi over 6 is positive root 3 over 2 and I have a negative. It can't be negative pi over 6 because that's not in my range of 0 to pi. It's got to be in that second quadrant, having a pi over 6 reference angle. It's 5 pi over 6. No calculator can help you with this. The calculator is going to spit out the decimal equivalent to 5 pi over 6. You can think through this faster than you can getting a calculator output and then manipulating that back into 5 pi over 6. We really need that to happen. We need you to realize that the tangent inverse of minus 1 is going to be a pi over 4 angle because that's what the tangents are. However, it can't be pi over 4 because that's in the first quadrant. Tangents in the fourth or first and represented as a negative in the fourth, and we're finished. And if we had something like secant inverse of, let's say, secant inverse of 2, that you would recognize that that's the same thing as the cosine inverse of 1/2. And you would recognize, oh, I know what angle to take the cosine of and get 1/2. By memorization, that's pi over 3. Now, cosine of pi over 3 would be straight out 1/2. That's my answer. That's what we're looking for. And if we had something like the secant, not the secant, let me do the cosecant inverse of negative root 2. Hopefully we know that that's the sine inverse of negative 1 over root 2, which is better known to us as root 2 over 2. When the sine inverse of root 2 over 2, well, root 2 over 2 is from a pi over 4 angle. It's not in the first quadrant. I have to be between negative pi over 2 and pi over 2. It's negative. And that quickly you're getting these guys. That's what we want out of this whole initial section. And then equivalently, if we did this, cosine of cosine inverse of any number between 1 and 0. So negative 1 and 1. So let me do 2/3. This thing is going to be 2/3. The cosine will undo the cosine inverse, no problem. The only time you have to pay attention is if the inverse comes last. Let's look at this. Sine inverse of the sine of 5 pi over 6. This question will always make a standardized test. It'll always make one of my tests because it really gets to the fact of whether somebody understands inverse functions. The answer to this cannot be 5 pi over 6. So for the person that answers 5 pi over 6, they're wrong because your answers have to be between pi over 2 and pi over 2. Negative pi over 2 and pi over 2 if the last thing you're doing is sine inverse. So we have to think for a moment. Talk to me about 5 pi over 6. Where is it? Well, it's in quadrant 2. Well, it's a quadrant 2 angle and sine's being applied to it, so that's positive. You're taking sine inverse of a positive number. This is going to be pi over 6 in the first quadrant. So you can minimize your work. Now, the maximum amount of work would be just figure it out. Just take it step by step. Sine of 5 pi over 6, that's a pi over 6 reference angle in the second quadrant. That's positive 1/2. Sine inverse of positive 1/2 is pi over 6. You could step it through like that. But ideally, you would do something like this. Cosine inverse of cosine of let me do 7 pi over 6. Ideally, this is what would happen. Because these guys are inverse functions of one another, you know that you're going to come out with an angle that's going to have a 6 on the bottom. The question is it pi over 6 or 2 pi over 6? Not 2 pi, sorry, 5 pi over 6. Is it pi over 6 or 5 pi over 6? Is it in the first quadrant or the second quadrant? All depends. What's the cosine of 7 pi over 6, positive or negative? Well, 7 pi over 6 is a third quadrant angle, so the cosine is going to be negative. We are absolutely dealing, sorry, I had that there before. I don't think we've done this yet. Let's see where we're at. We are absolutely dealing with, because it's negative in this quadrant, a second quadrant angle, and 5 pi over 6 is the desired answer. Again, what could somebody do? They could step themselves through this. Hey, cosine of 7 pi over 6, negative root 3 over 2. Cosine inverse of negative root 3 over 2? Absolutely 5 pi over 6. But we want to get some thinking going on there as well, trying to just remember, hey, these are only two possible answers out of this. So think about that as you go through and do the 6-1 problems. Let me know, come to Zooms if things aren't sitting well, but this, it's the base level, so it's not going to get too far away from us, but you want to make sure you're not getting frustrated. Make it simple if you can. So that's my advice. And don't hesitate to contact me via email with questions as well.